Hello guys, welcome again to my channel where we give you insights to all the questions giving you problem at school. It's math time questions and answers, and today's question is as a request from one of our subscribers, and the question is taken from Cameroon GCE board 2021, and it talks about graphing. The question says that given the function f of x, where f of x is equals to 5 plus 4x minus x squared, a, construct a table of values of y against x for which minus 2 is less than or equals to x and x is less than or equals to 6. Taking 2 centimeters to represent 1 unit on the x-axis and 1 centimeter to represent 1 unit on the y-axis, draw a graph of y equals to f of x. From your graph, determine the value or values of x for which x squared minus 4x minus 5 equals to 0. D. Find the gradient of the curve at the point 4, 5, giving your answer to 1 dp, 1 decimal place. Okay guys, from there we know that the function given to us is a quadratic function, so we need to expect what we call a parabola, a curve, which can be a mountain or a valley. So how do we know? From the equation given to us, we can know if it's going to be a mountain or a valley. So this equation has a coefficient of x squared to be minus 1. So if the coefficient of x squared is negative, then the graph will have a maximum turning point, meaning the graph is going to be a hill. But if the coefficient of f of x is greater than 1, then the graph is going to be a valley. If the coefficient of x squared is 0, then we are going to have a straight line. Then that equation is not going to be a quadratic equation. So for us to know if the value is going to be a hill or a valley, we need to know if the value of the coefficient of x squared is negative. If it's less than 0, then it's going to be a hill. If it's greater than 0, then it's going to be a valley, meaning it's going to have a minimum turning point. And if it's 0, then the equation is not going to be a quadratic equation, meaning the curve is not going to come out. Then we are going to have a straight line equation. So that's how we interpret quadratic functions. Now let's answer the question properly. In this case, we are going to have a table of values of y against values of x. So we are going to construct that our table there, and we are going to have, we'll break this this equation into different parts. We'll have the values of x within the range of minus 2 and 6. So we are going to break this f of x into 5, which is a constant, 4x term, and then minus x squared, and then we combine all of them, we add them to have the original value of y. So what do I mean? So we are going to have values of x, we are going to have the 5, which is a constant, we are going to compute values of 4x, we are going to compute values of x squared, and when we add the values of 5, 4x, and minus x squared, we are going to have our y. So our y is this f of x here, which is 5 plus 4x minus x squared. Now values of x are from minus 2 to 6. You can see that x is greater than or equal to minus 2 and x is less than or equals to 6, meaning the minus 2 and the 6 themselves are included in the equation. So we'll take values of minus 2, minus 1, 0, 1, 2, 3, 4, 5, and 6 itself. So that is the range of values which we are going to use to plot that graph. 5 is a constant, so 5 will remain 5. It does not depend on x, so it will remain 5 all through. So we'll have 5 there all through. Now the value for 4x, so we are going to take, if x is minus 2, what will be 4x? 4x will be 4 times minus 2, which is minus x. If x is minus 1, 4x will be 4 times minus 1, which is minus 4. If x is 0, 4x will be 4 times 0, which is 0. If x is 1, 4x will be 4. If x is 2, 4x will be 2 times 4, which is 8. If x is 3, 4x will be 12. If x is 4, 4x will be 16. If x is 5, 4x will be, that's correct, 20. And if x is 6, 4x will be 24. That's right. Okay, now we are going to compute for values of x squared. So x squared, we are going to have minus 2 squared, which is 4. We are going to have minus 1 squared, which is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And 6 squared is 36. So those are the values. Now our y is 5 plus 4x minus x squared. So we are going to have 5 plus minus 8 minus 4, because we have minus x squared, but we have values here for x squared, not for minus x squared. So for x squared, so this 4 and all the values of x squared, we are going to subtract it from the other values. So we are going to have 5 minus 8 minus 4, which is going to give us minus 7. 5 minus 4 minus 1, which is going to give us 0. 5 minus 0 minus 0 is going to give us 5. 5 plus 4 minus 1 is going to give us 8. 5 plus 4 minus 1, because we are adding 5 plus the values for 4x plus values of 4x minus the values for x squared. So that's what we have. So 5 plus 8 minus 4 is going to give us 9. 5 plus 12 minus 9 is going to give us 8. 5 plus 16 minus 16 is going to give us 5. 5 plus 20 minus 25 is going to give us 0. 5 plus 24 minus 36 is going to give us minus 7. So that is how we draw a table of values for y against each corresponding value of x. So our graph is going to depend on these values of x against these values of y, because y is what we have as f of x in this case. Okay, with this in mind, we are going to plot a graph of y against f of x. But before we do this, let me give you a clue about graph papers. So graph papers, you can see that we have from one thick line to another thick line, and in between them we have some smaller squares in between them, small squares in between them. So between one thick line to another thick line, we call it 1 centimeter. So if we say that 1 centimeter should represent 1 unit, meaning if you take this thick line to be 1, the next thick line to be 2, the next thick line to be 3, and the next thick line to be 4, and so on. But if they say 2 centimeters to represent 1 unit, meaning if you take one thick line to be 1, then number 2 won't be at the next thick line, it will be at the second thick line, so that you have 2 centimeters for 1 unit. From 1 to the next unit will be 2. So that is what we mean by 1 centimeter to represent 1 unit, 2 centimeters to represent 2 units. That's what we mean on a graph paper. And on a graph paper, all your vertical lines are what we call the y lines, and your horizontal lines, the line moving from left to right, are what we call the x lines. So to do this, we are going to draw our graph, y on the vertical axis and x on the horizontal axis. Now, the one rule again I want you to note about graphing is that your graph should not be hanging at the center or at one corner of the graph paper. your graph must occupy at least 3/4 of your graph paper, meaning your graph should occupy almost like this. So when you are choosing a scale, be very careful. But in this case, we don't even need to choose a scale. We need to just work according to the directive that have been given to us. And the directive says that we should take 1 centimeter to represent 1 unit on the x-axis, on the y-axis, and 2 centimeters to represent 1 unit on the x-axis. So we are going to draw our y-axis, and we call that the y-axis, which is f of x, and we draw our x-axis, and we call that the x-axis. Now we are going to take 1 centimeter on the x-axis to represent 2 centimeters on the x-axis to represent 1 unit. So meaning that if we call this point where these two graphs meet, these two lines meet, we'll call it the origin, the point 0. So from here we are going to move one thick line to another thick line. We call it 1 unit. So those are 2 centimeters, which will be 1. So we'll call that from there to there, we'll call it 1. And then from this thick line to the next thick line, we'll call it to the second thick line, we'll call it the point 2, which will be another 2 centimeters to represent 1 unit, because from 2 to 1 is 1 unit. If we move from there to the next 2 thick line, we'll call it 3, 4, the trend follows, 5, 6, and then 7, because our biggest value for x is 6, so we can just end at 7. On the left of that origin, on the left of that origin are the negative values for x. So again, 2 centimeters to represent 1 unit, 1 thick line. The second thick line will be -1. So at that point we'll have -1 there, and then from there to the 2 next thick lines will be -2. The trend follows. Now on the y-axis we have 1 centimeter to represent 1 unit, 1 unit to represent 1 centimeter. So from one thick line to the next thick line will be 1. From one thick line to the next thick line will be 2. So that's what we mean by 1 centimeter to represent 1 unit. So that's 1. The next thick line, not this small thick line here, the visible thick line will be 2, and the next will be 3, the next will be 4, the next will be 5, the next will be 6, 7, 8, and 9. That's how we have them there. So below the origin are negative numbers. So we have -1, same, 1 centimeter to represent 1 unit, -2, -3, -4, and -5. We cannot include more than that in this graph paper because it doesn't fit on the screen so well. So now let's start plotting the graph. Remember, our graph paper, so we can then start plotting the graph. So let's bring up a photo of this graph here and see the corresponding values of that we are plotting. So the corresponding values of that graph are that -2 is plotted against -7. When x is -1, we have -0. When x is 0, we have y to be 5. When x is 1, we have y to be 8. When x is 2, we have y to be 9. And those are the values we are plotting. When x is 3, we have y to be 8. When x is 4, we have y to be 5. When x is 5, we have y to be 0. And when x is 6, we have y to be -7. So those are the points we are going to be plotting. So on this graph, when x is -2, y is -7, but because of lack of space, we didn't include here. Okay, so we'll start with the next point, which says that when x is -1, we have 0. So we'll plot -1 and y is 0. So we'll plot it at -1 there. So that's what we are going to have. When x is 0, y is 5. So x is 0 here, y is 5. So we'll plot it at 5 there. When x is 1, y is 8. So when x is 1, where is x1? X is 1 here, we go up. Where is y? Y is 8 here. They meet at this point, so our point we are going to plot will be there. So when x is 2, y is 9. So where is x-axis? X-axis is 2, y is 9. We move. Where is 9? 9 and x, when x is 2, they meet here. So our next point will be there. When x is 4, 3 rather, when x is 3, y is 8. So where x is 3, y is 8 again. So we'll have the point of intersection there. So when x is 4, y is 5. So 4 running this way, 5 running this way, they meet at this point here. So that's where we'll have that. When x is 5, y is 0. So x is 5 here. Where is 0 line? 0 line for y here. So they will meet here. We have 0 there. And when x is 6, y is -7. So they will meet somewhere below there, but because of lack of space, we will not include it. So you see, because the coefficient of x in that equation was -1, x squared rather was -1, we have a hill. So we are going to plot a graph to draw a line, a curve, to join all of these points together to give us a parabola. So that is the graph of that quadratic equation. Now the next question says that B says that from your graph determine the value of x for which x squared minus 4x minus 5 equals to 0. So you see that this question, what they are asking us to solve here, x squared minus 4x minus 5 equals to 0, is slightly different from our original equation which we plotted the graph. Original equation is 5 minus 4x minus x squared. So we are going to modify this new equation, which is x squared minus 4x minus 5 equals to 0, to look like 5 plus 4x minus x squared. In that case, we can then use the graph of 5 plus 4x minus x squared to get the value of this equation. So how do we do this? Our original equation is 5 plus 4x minus x squared equals to 0. Our new equation now that they are asking us to look is x squared minus 4x minus 5 equals to 0. That's what they are asking us to solve, which is slightly different from the original equation. So but when we look at this new equation, we see that if we factor out -1 from here, what are we going to have? We are going to have this original equation. So I will factor out -1 there so that we can have -1 times 5 will give us -5 here. -1 times 4 will give us -4 here. -1 times -x squared will give us x squared. So if we factor out -1 here, we are going to have the original equation which we use to plot this graph, right? So what do we do next? We can divide both sides by -1. So if we divide both sides by -1, we are going to cancel -1 into that -1 is going to go, and 0 divided by anything is 0. So we are going to have 5 plus 4x minus x squared equals to 0, which is the same as the equation we have plotted the graph for. So if we are solving for 5 plus 4x minus x squared equals to 0, then we are going on this graph and draw the line where that equation, which is y, is equals to 0. So all of this we know it was y when we're plotting the graph, right? So we can say y is equals to 0. So if y is equals to 0, then we go, where is y equals to 0? This line of x here, this line. So this line here, we'll look at the line where the line touches the curve, then it will be our solution, y equals to 0. So the line touches the curve at this point 5 and at this point -1. So our solution to this graph 5 plus 4x minus x squared equals to 0 will be this point where the x-axis touches the curve, which is 5 and -1. Therefore x equals to -1 or x equals to 5. That's the solution set of that using the graph. Now again, For example, they can ask you to solve that equation. Instead of equals to 0, they ask you to solve it equals to 5, and we know that all of this is y. So if they say equals to 5, then we'll draw the line at where y is equals to 5. Where is y? 5. Y is 5 here. We'll draw a straight line here going through. So we'll see that what where the curve touches that line will be our solution set, and the curve will touch the line at 5 when x is 0 and when x is 4. So for this case, we need it when x is -1 and when x is 5. Okay, that's that. The next question is saying that we should find the gradient of the curve at the point 4, 5, giving your answer to 1 dp. So to look for the gradient of a curve at a point, we need to draw a tangent on that curve at that point. And what point are we looking for? 4, 5. 4, 5 means that what? When x is 4, y is 5. So they will meet here at this point here. So at that point, we should draw a tangent. A tangent to a curve is any line that touches that curve at just one point. So we'll draw a line, a straight line that touches that curve at this precise point that they have given us, 4, 5. So we put our tangent there. When we put our tangent, a gradient is simply rise on run. Rise on run, meaning change in y divided by change in x. So for us to get the rise and the runs, we are going to convert this tangent into a right angle triangle. So we are going to draw a right angle triangle at that point. So if we have a right angle triangle at that point, from here to the top of that right angle triangle is what we call the change in y, because y will be moving from this point to this point, so it is a change, and x will be moving from this point to this point, so it's another change. So the slope of a line is y2 minus y1 divided by x2 minus x1. y2 is simply the higher values of y, which will occur here, minus the lower values of y, which will be y1 here, and x2 will be the higher values of x, which is x2 here, and x1 will be the lower values of x, which will occur here. So from this right angle triangle, the higher values of y will be at this point, which correspond to this middle line, and since from 7 to 8 is 1 unit, so in their middle it will be 0.5. So the higher values of y will be 7.5, and the lower value of y will be from this point corresponding to 2, while the lower values of x will be from this point going here. This middle is 0.5, right? So this one will be less than 0.5. It will be about 0.3, because we have one line here, 0.4, 0.5, 0.3, which is 3.3, and the higher values of x here will be 5. So therefore the slope will be 7.5 minus 2, 7.5 here minus this 2 here, divided by 5 minus 3.3 here, and the slope will be 5.5, because 7.5 minus 2 is 5.5, and 5 minus 3.3 is 1.7. If we divide those two values, we'll have the slope to be 3.2 something something something, but because they have said in 1 dp, we converted it to 1 dp to be 3.2. So guys, that's how we handle questions on graphing, quadratic graphing. So if you have any question, don't hesitate to leave it on the comment section, and then we'll attend to it as soon as possible. Stay with me, and don't forget to subscribe to my channel, like, share, and hit the notification bell for more upcoming videos. Stay blessed. Bye bye.